In this example, we are going to look at multiplying rational expressions. We have a combination of binomials and monomials in this example. So we have a couple binomials, and then we do have one monomial, all right? And to multiply rational expressions, we want to factor all of our numerators and denominators completely. We're going to cancel any factors that may be the same between our numerator or our upstairs and the fraction or rational with the downstairs or the denominator of our fraction or rational. Is another way to think about it, okay? And then once we do that, we will multiply across. Now, if we've done our factoring correctly, we should not have anything left, but it's always a good practice at the end to go ahead and just double check that it is in simplest forms. So if you need to, we always check, but if we've done our process correctly, we shouldn't have any of that. But it never hurts to double check. So looking at what we have right here, I have k plus m, the entire quantity squared, over k minus m. That is being multiplied by a k upstairs over k squared plus km. So we're going to use a couple different factoring strategies. Now, before we start, let's just look real quick. We have a k plus m squared. I am going to expand this. I always expand anything like that and have the two that are there. Now, I mean, we're only handling two of them. If it were something very large, we may not do that. But for our purposes at this level, I recommend it just to make sure you don't lose one of your binomial factors. Downstairs, this will be in its simplest form. There's not a lot we can do, and we'll talk about that. Upstairs, we have a k, and that is over k squared plus km. So I'm going to go ahead and just scroll down a little bit, give us some room, and we are going to start. So I like to draw my line here and looking upstairs. So I may color this a little because we have a lot going on this problem. We have k plus m, and that exponent upstairs means the entire parentheses is squared. Now, you do not want to factor this. I'm sorry, you do not want to FOIL this. You don't want to reverse the factor. You don't want to multiply, okay? Leave it in its factored form, but you want it factored completely. You want to expand the factorization here, but you do not want to multiply. Downstairs, I am going to leave this k minus m. So actually, I'm going to do that in a different color just to kind of distinguish between what's going on. So, and we'll leave him in black because we're not really changing him yet. We're going to talk about that in a second. The multiplication can stay, my little line here. This k upstairs, again, I'm not changing it, so I'll leave that one black as well. And then coming downstairs, we're going to use my favorite pink. This k squared plus km, this needs to be factored. It's going to involve a little more work. So I'm just going to come over here to the side, kind of. Let's talk about it. It was k squared plus km, correct? Okay, great. So we have k, one second. Okay, k squared plus km. Now, anytime we're factoring, the first thing we want to look for are GCFs. We have a common factor, right? We have two k's. There's a k here and a k here. There's two terms containing k. I will remove that k. So we always take out the lowest exponent. So if we have 2 and 1, the lowest is the k to the first. And when we are factoring, we're really just undoing distribution, right? That's another way to think of it. We're reversing distribution. K2 over K1 leaves me with a k. And these two k's will cancel, leaving me with m. Now I'm going to replace that over here in my expression. So we have k times k plus m. Okay. Now we factored everything. I noticed something. So I do want to review one property before we do this, just so that we have all the pieces we need to completely solve our problem. Okay, looking at what we have k plus m over k plus m, right? Downstairs, we have a k minus m. So just kind of paying attention, talking about some things. This is not quite an opposite. I do want to just mention opposites in brief because that will come up later on in this section, and hopefully you've already seen a little bit with that, but if not, I do want to talk about it just to make sure we understand when we can cancel things and when we cannot. So when something's exactly the same, we cancel it. So if they're exactly the same, like if it's k plus m over k plus m. Now an opposite would be something if we have k minus m over m minus k. And I just kind of want to elaborate a little on that. if you have exactly the opposite terms, and I show in class this typically, like I'll factor. So say I want to factor a negative out at the top. We know about factoring. We just did a little bit of factoring up here, right? If I just take a -1, so if I, and I'll just do this over here, if I take my k minus m, I take a -1 out, you're really dividing both of them by -1, right? You get negative k plus m. So, oh, I didn't mean to do that. I apologize. Looking over here, what ends up happening is you have -1, and you're going to have your negative k plus m over m minus k. Well, if I want to take that a step further upstairs, I can just reverse these. I can rearrange and write terms in any order as long as I keep the signs. We've seen that throughout our algebra this semester. You're going to have m minus k over m minus k. So do you see when you have an opposite? And I mean, another way, I'll show you another way to think about it in a second. But if you have the exact same terms, so if you have an M and a K and an M and a K, and they have exactly opposite signs, then when you cancel them, what's going to happen? Every time, you never ever have to do this work again. They're going to cancel out and leave you with a -1. So what I want you to take away from this, and I just wanted to emphasize it because this almost looks like an opposite, but it's not. And I just really want to make it clear. If you have exactly the same case, so like what we have, I'm going to erase this up here and just show you just to make sure we're really clear on when we can cancel and when we cannot, because it's about to get a lot more complicated, right? If you have exactly the same, so if you have the same factor, if you have the same factor like k plus m over k plus m, when we cancel those two out, it equals 1. So we'll cancel both of our factors out. And I highly, highly recommend always leaving parentheses because it helps you make sure you cancel the whole binomial. If you can't cancel the whole thing, you don't cancel it, right? Good. Now, if they're exactly the same, you cancel. If they are exactly opposite, and this can look like a lot of things. It can look like that. It can actually look like this. And this one might actually even be easier to see. There's a lot of variation, but if they're the same two factors, top and bottom, but they have opposite signs, when you cancel them, it's just going to be -1 every time. And then there's other things like what we have in this problem that you actually cannot simplify. So I just really wanted to emphasize, if it's not one of these two, we're going to leave it alone. So what we have right here, k plus m over k minus m, this is neither exactly the same nor exactly the opposite. So we will actually leave that guy alone. Now I'm going to start canceling, but I just really, really, really wanted to make sure that we emphasize that before we went any further. So I have a k plus m here and a k plus m here. Next, I have, let's do orange, a k upstairs and a k downstairs. And last, when we come over here, we're going to multiply across our top, multiply across our bottom, k plus m over k minus m. You cannot simplify this any further. And I like to, like I mentioned a second ago, leave the parentheses because often a very, very common mistake, and I understand why it happens, is to want to cancel these k's or cancel these m's. You cannot cancel part of one of your binomials. So you have to leave them like that. Okay, so if you leave the parentheses, it really kind of helps you to make sure when you're first starting out that you don't do that. But our final answer for this problem would be k plus m over k minus m.
You are currently the